Hello students, welcome to another session of this three-dimensional geometry, and today we'll be discussing something about plane. In the last 12 sessions, we all discussed something about straight lines, lines in space, how that equation of line can be derived, and many more things about straight lines. Now we'll be dealing with planes. As you all know, what do you mean by plane or how it looks? The surface like this we call as plane. It is almost known to everyone. And maybe in your mind you have a question. Do the planes have their own equation, or can we derive equation of equation of planes? Yes, equations of planes can be derived. So, but in order to derive or determine the plane, you must require some information. Then only you can derive the equation of a plane. So, what are the things to be required to determine or derive the equation of plane? So, let's understand. A plane is uniquely determined from the following known things. Okay, so what are the information required? Let's see here. First one, the normal to the plane and its distance from the origin is given. Look at this. Suppose this is the plane and there is a one line drawn from the origin. Suppose this is perpendicular to the plane, then this line is called the normal to the plane. And if its distance is known, then you can construct the equation of this plane. This is the one information that you require. Other thing is, if it passes through a point and is perpendicular to a given direction. Suppose that if you know that this plane is passing to certain point, and if you also know that it is perpendicular to some given direction. Suppose this plane is perpendicular to this direction and it passes through a certain point, then also you can determine or construct equation of this plane. So this is the second case in which you can construct the equation of plane. Third one is, it passes through three given non-collinear points. Okay, so suppose if you know that the line is passing through three non-collinear points, means points not lying on the same line. So in such case also you can construct the equation of the plane. So in all the three cases we will be deriving equation of plane. So let's derive very first equation of the plane, that is in the normal form of a plane, means with the given information in case of as we studied first one. Okay, so in the exam you could be asked to derive the equation of plane in the normal form. As I said, normal means a line drawn from the origin and perpendicular to the plane. Suppose this is the plane, then this is called normal. So let's derive the equation. You can have derivation in vector form as well as Cartesian form, and you could be asked to derive both the forms in the exam. Okay, so let us see here. So here is a plane and this ON is the normal. So just imagine that this is your ON and this is your plane. So imagine this and assume that the length of the normal is D. So consider a plane whose perpendicular distance from the origin is ON is equal to D. So this is the normal, or you can say that it is a perpendicular drawn from the origin onto the plane and whose length is D. So let us assume this much. Next, let us take n cap. N cap is the unit vector along this normal. So let n cap be the unit vector along the normal ON. Now see here how the vector can be expressed ON. So vector On can be expressed as its magnitude into its direction. As we all know, any vector can be expressed as the product of its magnitude and its direction. So what is the magnitude of this On vector? It is length, that is d, and its direction is n cap, because n cap is the unit vector along On that we all studied. Now take any point pxyz on the plane. So let us take any point pxyz on the plane. Then, as we all know that the position vector of P is represented as R. So let us take vector R as position vector of this point P. So OP is equal to vector R, and which is expressed as xi cap yj cap plus zk cap be the position vector of P. Now join this Pn. So join this Pn. As we all know that if you join this Pn, definitely this is perpendicular to On. Okay. So if you want to imagine this, or if you want to realize this, suppose this is your On and this is your plane. So if you mark any point on the plane, so if you mark any point on the plane, if you mark any point on the plane on the book here on the surface, and if you join that to the point N, that will be definitely perpendicular to this line. So that is why Pn is perpendicular to On. And as we know that by the condition of perpendicularity of vectors, if two vectors are perpendicular, then their dot product is 0. So that is what np dot On is 0. And express np in the form of position vectors that I told you. So vector np can be written in what way? It can be written as op minus On. So this vector np can be written as vector op minus vector On. And as we have seen vector op as vector r and vector On as d n cap. Okay. So now divide, d is constant, so divide throughout by d. So either you can d right here, no problem in the dot product. So dividing throughout by d, so what you will get, this d cancels, this d cancels, so you left with this. Now distribute this dot n cap. So take this inside, distribute, what you will get, vector r dot n cap minus d in n cap dot n cap. And as we know that the dot product of two similar vectors is its magnitude square. So here is the thing, vector r dot n cap minus d magnitude of n cap square. And as we know that n cap is what? It is a unit vector in the direction of normal. So its magnitude is 1. So you left with, so vector r dot n cap minus d is equal to 0, because n cap is unit vector, so its magnitude is 1. So if you transfer d this side, so you will get vector r dot n cap is equal to d. So this is the equation of plane in vector form. Okay, so you will be asked to derive this. So remember this. Now we will be deriving in Cartesian form. So using this, very simple, vector r is what? It is xi cap, yj cap, zj cap, and n cap is a unit vector, means its magnitude is 1. So you have to take one general vector n cap, that is having direction cosines lm n. So that's the thing. So let us derive in Cartesian form. So let us assume that lmn be the direction cosines of n cap. This you have to assume. So then n cap can be written as what? Li cap plus mj cap plus nk cap. Okay, so if Lmn are the direction cosines, then vector n cap can be expressed in the component form Li cap mj cap plus nk cap. Remember that what is its magnitude has to be 1. So if you find the magnitude of 1, n cap, what will get? Square root of L square plus m square plus n square is equal to 1. Okay, so this is the why. This is why you have to take n cap as Li cap plus mj cap plus nk cap. Now substitute this and your vector r in this equation. Vector r is known to us. It is what? It is xi cap plus yj cap plus zj cap, and dot n cap is this. Okay, so d as it is. Now find the dot product of these two. As we know that how to find dot product of two vectors. It is sum of the product of the coefficients of I, j, k. So x into L, y into m plus z into n, or you can write Lx plus my plus nz, which is equal to d. So that is the Cartesian equation of the plane in normal form. Okay, so the dot product of these two is this much. So this is the Cartesian equation of the plane in normal form. So remember that Cartesian equation and vector equation of the plane in normal form. So this is your vector equation and this is your Cartesian equation in normal form, where d stands for length of the normal drawn from the origin. Okay, so this is important, d. So please try to understand and derive it 2-3 times. Don't by heart. If you by heart, you will never reproduce it in the exam. So understanding the concepts is important. So we will have some note on this. So look at this. Please note this. As we know that vector equation of a plane is normal form is this, and n cap is this much. So suppose you are not given the direction cosines. Okay, so this is the standard one where Lmn stands for direction cosines of the normal. But sometimes what happens, you will not be given direction cosines, but you will be given direction ratios of the normal. So in that case, what will be the equation of the plane? So that is the case to be understood. So if A, B, C are direction ratios of the normal to the plane, then as we know that the relation between direction cosines and direction ratios. Okay, so we have discussed how you can find direction cosines from direction ratios. These are the formula that we derived. So substitute the direction ratios and you will get direction cosines. Okay, so if you substitute here Lmn, so you will get this. So L is what? A by square root of a square plus b square plus c square. M is this much and n is this much. So throughout you have common square root of a square plus b square plus c square. So it is common here and you will get ai plus bj plus c equal to d. So if you cross multiply, if you bring this root term this side, so what you will get? You will get equation in this form. Okay, we had this in the denominator. So bringing it, you will get this. So what is the general formula for this? You will getting like this: vector r dot ai cap plus bj cap plus ck cap into something new constant, that is d. So where d stands for this. So this is something. So this is again one general equation of the plane, or you can say that the equation of the plane in normal form, where a, b, c are direction ratios. So this also represents a plane. So you may write it as vector r dot vector n equal to d, where vector n, earlier we had n cap, remember this. Okay, so here n cap stands for normal vector, or it is a vector whose direction ratios are a, b, c. Okay, so any equation of this form can also represent a plane. So you will understand when you study problems. So any equation of this form can also represent a plane. So where the coefficients a, b, c stands for, they are the direction ratios of the normal, and the distance of the plane from the origin is given by the formula d is equal to, you can find this d by using this formula. D is what? D divided by square root of a square plus b square plus c square. Okay, so if you are given like this, means we know the direction ratios of the normal, then you can calculate the distance from the origin by this formula. Okay, so let's understand with help of examples. So here is a first example. Find the vector equation of the plane which is at a distance 7 units from the origin and normal to the vector 3i cap plus 5j cap minus 6k cap. So d is given and normal vector is given. Okay, so you are not given n cap, but you are given vector n. So how to identify whether it is a n cap or vector n? So just find the magnitude. If its magnitude is 1, it is n cap. If its magnitude is not 1, it is a normal vector. Okay, so given d is 7 and the normal vector to the plane is vector n. So as I said, normal vector, you are given this vector. You are given this vector. This is your normal vector and you are asked to construct or equation of this plane. So this is the thing you know. So let us move. So first you have to find what are the direction cosines of the unit vector. Okay, so as we know that the vector equation of the plane is given by vector r dot n cap is equal to d, and we don't have n cap with us, we have vector n with us because its magnitude is not 1, so it is a vector n. So you have to find n cap, and that we know how you can find unit vector in the direction of normal means vector n divided by its magnitude. So this is your given vector n divided by its magnitude. So simplify it, square this, you will get this. So this is the unit vector in the direction of normal, that is n cap. So the vector equation of the plane is given by vector r dot n cap is equal to d. So substitute or n cap. So this is your vector equation of the plane. So very simple. You must know the basic concepts. So otherwise just by hearting the problems or formulas won't help you in this 3D geometry. Conceptually you must be very good. So let's have one more example on this. Find the vector equation of the plane which is at a distance 9 units from the origin and the normal to the vector is 2i cap minus 3j cap plus 4k cap. Okay, again you are given vector n because its magnitude is not 1, so definitely it is a normal vector. Okay, so that you have to study. I will show you. So what you have to do is find okay, I'll solve it. So here you are given, so you are given d is given. Okay, so distance of the plane from the origin is 9, d is given, and you are given n cap, vector n is given. So vector n is given 2i cap minus 3j cap plus 4k cap. So you have to find n cap. As we know that it is given by vector n by its magnitude. So it is 2i cap minus 3j cap plus 4k cap divided by its magnitude, means square root of 2 square plus 3 square plus 4 square, and you will get 2i cap minus 3j cap plus 4k cap divided by square root of 16 plus 4 20, 29. You will get square root of 29. So equation of the plane is okay. So it is vector r dot n cap equals to d. Just substitute here. It is r dot vector r dot 2i minus 3j plus 4k, you can write cap also, divided by square root of 29 equals to 9. So in this way you can find equation of plane from the given distance and given normal vector. So let's move on to next example. Find the Cartesian equation of the plane vector r dot I plus j minus k cap is equal to 2. So you are given Cartesian equation, so you are given vector equation, and from this you need to construct Cartesian equation. So what is Cartesian equation? It is Lx plus My plus Nz equals to D. Okay. So first of all you need to find what is D. Okay, this is not your D. This will be the D when this is your n cap, means if this is a unit vector, means if its magnitude is 1, then whatever this quantity, that stands for D. So right now what is the magnitude of this? It is square root of 1 square plus 1 square plus 1, that is you will get root 3. So it is not a unit vector, so it is not D. So first you need to find what is unit vector, means n cap you have to find, and from that you can find its direction cosines. Okay. So your answer directly you can write. Okay, if you get it for 1 mark, so directly you can write from the given equation. What is it? Cartesian equation means you can just write x plus y minus z is equal to this number, but I will show you how it will be. Okay, so for 1 mark you can write directly. If it is asked for 2 marks, find the Cartesian equation, then you have to do all the things that I'll be doing. So first you have to write the given equation as this, and dividing both sides by magnitude of vector, your vector n. So divide its throughout by its magnitude, then only it becomes unit vector. Okay, so dividing throughout by root 3. So what you will get? It is I by root 3, j by root 3, k by root 3 equal to 2 by root 3. Now this is your unit vector. This is your n cap. Okay, because you are dividing this vector by its magnitude, so definitely this is your n cap. So if this is your n cap, then definitely this is your distance d. So this is in the form r dot li cap plus mj cap plus nk cap equal to d. So here L, M, N are the direction cosines. So what are they? 1 by root 3, 1 by root 3 minus 1 by root 3. So In the Cartesian equation, what is the Cartesian equation of the plane? This is Lx plus My plus Nz equal to D, and we know that L is 1 by root 3, M is 1 by root 3, and N is minus 1 by root 3, and D is 2 by root 3. How it is means, just see here. This is your D, this is your L is 1 by root 3, 1 by M is 1 by root 3 minus 1 by root 3. So this is the Cartesian equation, or you can multiply throughout by root 3. So what will get? Root 3, root 3, root 3 cancels everywhere. We will get x plus y minus z is equal to 2. So from the vector equation, you can write the Cartesian equation directly if it is asked for 1 mark. Otherwise, if it is asked for 2 marks, then you have to do the things what I have done. Okay. So in this, you have to remember. So there is one more example for this, for your understanding. Find the Cartesian equation of the plane vector r dot 2i plus 3j minus 4k cap is equal to. You can write directly for 1 mark. If it is for 1 mark, then you can write directly what it is. Its answer is, as I said earlier, instead of I, j, k, you can take x, y, z. So its Cartesian equation can be 2x plus 3y minus 4z is equal to 1. So this is direct way of writing Cartesian equation from the vector equation. Okay. So otherwise you can do it. Okay. So this is one more example. Find the Cartesian equation of the plane. As I said earlier, what's the answer is 3x minus y minus 2z is equal to 7. If it is for 1 mark, if it is for 2 marks, then divide throughout by what you have to do? Divide it by magnitude of this. I will show you. So dividing by, this is your vector n, because its magnitude is not 1, that you will come to know here. So divide by 3 square plus 1 square plus 2 square, that will get 9 plus 1 10, for root 14 you will get. So on dividing, you will get vector r dot 3 by root 14 I cap minus 1 by root 14 j cap minus 2 by root 14 k cap is equals to 7 divided by root 14. Now clearly this is your unit vector, means this is in the form Li cap plus minus mj cap minus nk cap. So from this you can write L is equal to 3 by root 14, M is equal to minus 1 by root 14, and N is minus 2 by root 14. So therefore equation of the plane in Cartesian form. What it is? It is Lx plus My plus Nz is equal to D. So substitute here. So that will get 3 by root 14x minus 1 by root 14y minus 2 by root 14z equal to d is this much, 7 by root 14. So if you multiply throughout by root 14, so what will get? Finally, you will come up with 3x minus y minus 2z is equal to 7, as I said earlier. Okay, so you can write directly or you can find in this way. So here is the example. Find the direction cosines of the normal to the plane and distance from the origin from the given equation. So you are given one equation of the plane, that is 2x plus 3y minus z is equal to 5 in Cartesian form you are given. So you are asked to find direction cosines, means L, M, N are asked, and also you are asked D. Okay, so this is your Cartesian equation. So divide throughout by square root of 2 square plus 3 square plus 1 square. 2 square plus 3 square plus 1 square, that is root 14. Okay, means we have to make it as a in the form of Lx plus My plus Nz. Once if you come to know that it is in the form of Lx plus My plus Nz is equal to something, then that something is the D. Okay, so that is why you divide it by this quantity. Okay, now definitely if you square and add you will get 1. So definitely these are the direction cosines. So direction cosines of the normal to the plane are 2 by root 14, 3 by root 14 minus 1 by root 14, and whatever the quantity will get, this is your D. Okay, so in this way you can find the direction, cosines and the distance from the origin by expressing this given general equation in the Lx plus My plus Nz equal to D form. Okay, so any general equation can be expressed in the form of Lx plus My plus Nz equal to D. So here is one more example. Find the direction cosines of the normal to the plane and distance from the origin from the given equation. So you are given this plane. So its magnitude is not 1 here. If you find 1 plus 1, you will get 3. Okay, that is square root of 3 is this one. So you can divide throughout by this square root of 3. Now you can, if you square and add them, definitely you will get 1. So this is of the form Lx plus My plus Nz equal to D. So these are the direction cosines L, M, N, and this is your D. So you could be asked for 1 or 2 marks. So just build up your basic concepts. So similarly, find the direction cosines of the normal to the plane and distance from the origin from the given equation of the plane. So let us do this. So what I will write given as, okay, so let me write this. You are given 5y, you can write it as minus 8. Okay, so divide by what? There is only one term here, so divide by square root of 5 square. Square root of 5 square is what? It is 5. So what will get? Dividing by 5, you will get y is equal to minus 8 by 5. So from this you can conclude that, or you can express it in the form of 0x plus 0y plus, 0x, you can write it as 0x plus y plus 0z is equal to minus 8 by 5. So from this you can conclude, so L is what? 0, M is 1, and n is 0, and d is, okay, d is what? It's a distance from the origin, so it's always positive. So you can take it as just modulus of minus 8 by 5, that is 8 by 5. So you can conclude that L, M, N are this and D is this much. So very simple if basic concepts are clear. So here is the solution. Okay, so here is the solution. You can take screenshot of this or pause the video or note down. Okay, I hope you understood. So here is one more example. Find the distance of the plane from the origin. Here you are asked just D. So in order to find D, you need to express this in the form of Lx plus My plus Nz. Okay. So let me show first. Given can be written as, how will you write? Given can be written as 2x minus 3y plus 4z equal to 6. And as I said, divide by square root of 2 square, 3 square plus 4 square. So what will get? It is 16 plus 4, 29 you will get. So divide by this, you will get 2 by root 29x minus 3 by root 29y plus 4 by root 29z equal to 6 by square root of 29. Definitely if you square and add these things, you will get 1. So that is why these are LM. So this is in the form of Lx plus My plus Nz equal to D. So where L stands for 2 by root 29, M stands for minus 3 by root 29, and N stands for 4 by root 29. Therefore, D is 6 by root 29. Okay, so one thing to be noted, if you square and add, definitely you can verify your result. Okay, so if you square and add these things, you will get 1. So that is why these are the direction cosines. So in order to find the value of D, it is very much essential to bring it or bring any plane, given plane, in this form Lx plus My plus Nz by dividing this quantity, square root of 2 square plus 3 square plus 4 square, like this. So understand this. So here is the proof. Better you can take the screenshot or do it yourself once again. Okay. Now find the coordinates of the foot of perpendicular. Okay. So we will be dealing with this in the next class in detail. So right now you study how to derive the equation of plane in normal form, both in Cartesian and a vector form, and simple examples, and we'll be dealing with again one important concept from the point of examination, finding the coordinates of the foot of perpendicular, in the next class. So till then, take care, bye, keep studying.